Right. Hello, ngHouston. All right, we're doing. This is normally one of our in-person meetups. We got a few people here in Houston, but we're going ahead and broadcasting our guest today. We're lucky enough to have Jeff Whelpley join us here to talk about DevOps for Angular developers. So. Jeff, how you doing?
I'm doing well. How are you doing today?
Good, good. We're really excited to have you on.
Yeah, I'm excited as well. This is a topic that I've started to get into more and more over the last 6 to 12 months. And so it's something that I've been meaning to kind of come out with some blog posts and talks about. So this is actually the first one of hopefully a series of different things I'm going to kind of put out there. And so I'd be really interested in getting people's feedback who are listening to it, for sure.
Great, great. All right. You want to share your screen? You got some slides here?
Yeah, so let me get started. So give me a second to share. All right, does everyone see my screen?
Yeah, we can see it.
Okay, so like I said, my name's Jeff Whelpley. I'm the CTO of a company called GetHuman. Traditionally, we've had tools to help people get in touch with companies. More recently, as I'll talk a little bit about later in this presentation, we've started to branch out to do a number of other things. Like anybody else, and probably everybody listening, I do in one way or another have had to interact with DevOps type stuff, at the very least, cloud computing, AWS, something to deploy the apps that we build. And so I'm an Angular developer. I'm an Angular GDE, Google Developer Expert. And that's what has been most of my focus over the past 4 to 5 years. And if any of you guys are like me, you try to think as little as possible about DevOps and the actual intricacies of what goes on in the cloud. You're more care about building your app. And so when I put this together, typically when I try to put together a presentation, there's always should be like a problem you're trying to solve, and then what do you want people to get out of it? And so for this particular one, the problem is the fact that, again, if you're like I was, a lot of the intricacies of DevOps and cloud computing is somewhat of a black box. Like you use some stuff and you learn what you need to know, but generally speaking, like there's a lot of stuff that you don't know. And the thing that I want people to get out of this is I'm going to go over a lot of different things, but I really want to try to get people to have a better, just general feel for the major cloud environments and feel a little bit more comfortable leveling up and going deeper than probably you're comfortable at right now. So to start off with, I want to talk about history, and actually, I'm going to tell a story. It's a story of okay. So if you guys are a younger developer, you might not even know what this is. I can't see people's hands, but maybe Keith, you could tell me. Everyone raise a hand if you've actually physically touched or seen in person one of these things.
Yeah, we got a couple of hands up here. Yeah.
Okay, that's good. That's good. So I graduated back in 2000. Did a couple consulting gigs or whatever, but eventually I started working for Wells Fargo, big, huge bank. And back in 2004, I was running the team that did the loan origination system there, processing millions of loan applications every day. But even though I was the manager of the development team, a large part of my job, a crazy amount of my job, was dealing with physical, like literal physical servers that were in the basement of our building. Like it's just with the way things are right now, it's just crazy to think back to this time, and so many like just stuff that honestly, it's one of those things like with any bad experience in your life, you kind of like push it out of your mind and forget that it occurred, because many nights I would get called up on my pager for one of these physical boxes going down, and I would have to like drive to work, go in here, like try to reboot the box, like figure out what was happening. So this is like a nightmare to me. Like this is not a nice scene by any means. So a couple of years later, now these dates that I'm going to show are not the dates when this stuff actually first came out per se. These are the dates when, from my experience, I started like using them and being aware of this stuff. So like for VMware, I think it came out way earlier in the 2000s, but around 2006 was when enterprises really started to consider and use them for the first time. And for me, this was like my first view at like a better world than the sort of nightmare that I was dealing with in trying to get access to machines to deploy my stuff and just deal with spending an inordinate amount of time with actual physical hardware. The only problem was that when VMware was originally introduced, at least in Wells Fargo and the big companies that I was aware of, it was the type of thing where you had a bunch of infrastructure, local infrastructure ops people working at the company, and instead of empowering developers, which I think was sort of the point here, to run their own stuff, a lot of times the ops people just took even more control. And even though the promise was there of actually being able to free yourself from kind of the pain of dealing with not only the local infrastructure ops teams and hardware stuff, like it actually still was pretty painful, but sort of the promise was there. In 2008 was the first time that, again, I think Amazon EC2 was available earlier than this, but at least for us when we started talking about it at Wells Fargo. But I distinctly remember so many conversations with people that just thought it laughable that they would ever outsource and put in the public cloud any resource at Wells Fargo. Like this was just like unthinkable. And like I tried for a little while to argue it, and it just like did not go anywhere. Of course, a couple of years later, like obviously when I left there and was free to do whatever I wanted, I started using it in earnest and learning a little bit more about Amazon and some of the cloud-based services. And then really the biggest change, again, in my own history and timeline, and I'm sure a lot of you guys now in this room remember this as well, is back in the days when Firebase first came out, how amazing was it? And it wasn't just Firebase. Like Firebase I'm putting here as kind of a representation of some like backend as a service type services that came out around the same time, where the promise was this amazing thing for developers where you could just focus on your front end app and not worry at all about the back end. Like this was just like the idea of this was so great. And I think that the execution of this by different companies was spotty at times, depending on, and not Firebase for like other ones, but Firebase I always use as like the one who nailed it, like in terms of what they were trying to do with the original Firebase database and some of the services they had. Like they just did like a really good job of where to draw the line, how to like make things easy. And I think the adoption rates of Firebase kind of show and prove what I'm saying. And so jumping ahead to 2018 here, there's a lot that's happened, in between a lot of these timeframes. But when I think about cloud computing and what I think now and today about how to encapsulate the current state of cloud computing, there's actually kind of three things that I think, obviously there's a ton of stuff and a ton of things I could talk about, and I will talk about in this presentation. But if I had to summarize, I could kind of boil it down to three kind of representation areas. So one is represented by a class of these services that are now available, like, so not only this one, but like what Google has and recently came out with, which is called Cloud AutoML. And AutoML Vision is one of these services, but AutoML is the class of services. So has anyone here, you have to tell me, Keith, if anyone raise their hand, but if you raise your hand if you've heard of Cloud AutoML?
No, I haven't either.
Okay, great. So you guys have probably heard of machine learning in general, right?
Yep. Heads nodding.
Great. Yeah. So machine learning is the way in which you use neural networks to be able to create models that you can use to predict things in a way just like with the human brain. And actually, way back in the day, because I actually did neural networks in college back in 1999, and I spent my entire year building my own neural network, and it was like a huge, massive effort. And like, I mean, I think the only thing I predicted was whether when I flip a coin, if it's the chances that it's going to be heads or tails or something really silly. And now we have these various services at different levels within both Google and Amazon for helping do machine learning. So like some of them, before you get to, so AutoML is one of the newer ones that I'll mention in a second, but before this, there was like TensorFlow, which is basically a software that you can use to build your own neural network and run locally, and it's open source. But then Amazon and Google come out with higher level machine learning APIs. And so the deal with the higher level ones is that they have like pre-baked models. So for like, they have a pre-baked machine learning vision model, so that if you just, all you have to do is at an API level, send it an image, it'll give you a response with a whole bunch of labels of what it thinks that image is. So you send an image of a cat, it'll tell you like cat and maybe like black, and like it'll give you like a whole bunch of different things. The only thing with that is that that model, both on the Amazon side that have this and the Google side, it's just their pre-baked model. And for up until AutoML, it was just those two extremes that you just had to use their model, and whatever they give back, you can't change it. Whatever they give back, they give back. Excuse me, as a response. Or you go to the other end and you use something like TensorFlow to like build your own neural network. AutoML is something somewhat in between, where you use the pre-baked model as a starting point, but then you can train it with your own data. And they have this in different areas. So for vision or image recognition or something like that, you could train, if you had a data set, let's say a proprietary data set where you were creating widgets of, let's say, masks for people like Harry Potter, or I don't know, something silly like that. And so you had people with images who had that on. The pre-baked model might just tell you, like, if you showed an image that, okay, they have masks, like humans with masks, or like something generic. But then if you had your own data set, you can enhance their pre-baked model and then give it your own kind of like labels and other things on top of it, and basically train it to do what you want. So it allows you to take the pre-baked models and then kind of build on top of that, all without actually knowing what a neural network is at all. And that's the key part, and that's why I bring this up as my first thing, is kind of the state of where cloud computing is right now, because this particular service, AutoML, is amazing. The fact that you can use these stuff that's already great, like already gives you artificial intelligence in a really great way in their pre-baked models, and you can actually customize it to exactly what not exactly, but as long as it's somewhat similar, your needs for your business, and customize it to your needs is, I mean, amazing. Like it's just, I don't know. I don't think that people necessarily fully appreciate how amazing this is. So definitely, you guys should check this out, but it's also just to give you an idea of that machine learning and a lot of the stuff that they have in the cloud right now is one of like my big three of signifying where we are as far as cloud computing and cloud computing services.
Hey Jeff.
Yeah.
Maybe you're going to get into this, but on this, like, uh, when trying to think of use cases for when a business might actually want to get into this and adopt it. Do you have some good practical examples for
Yeah,
when
yeah, yeah,
someone
yeah.
might want to get into it?
Yeah, so one example is on GetHuman, people submit free text, like just a block of text saying what their issue is. Um, so they say like, oh, so the whole thing with GetHuman is that you're trying to get in touch with a company because you have a customer service related problem. And so as part of the process, when you go to gethuman.com, you would enter in some information about what your customer service problem is. So there's some structured data to specify, the company, but then there's also just a big block of text of like, tell me what the problem is. And so we do some analysis using AutoML, some other stuff to basically analyze what it is they're saying and classify it. So classification is a very traditional machine learning problem to solve. You basically, whether it's a block of text or an image or a voice, you're taking that input and then you're outputting some levels of tags that help you to then process it later. And so for us, the tags that we wanted for this block of text, there's some stuff that just picking out like the company name and some other stuff. But for us, like we wanted to know, for example, is this person irritated or not? Are they happy? Is this an emergency issue or not? Like there's like all these like little things that you can tell. Like if you were a human reading it, you could sort of tell just by their tone and the way they're doing it. They're like, oh my God, this person is like really upset. We got to like get back to them right away. Versus like, oh, this is not that big of a problem. But to have a machine do it, if you tried to like write your own kind of if then statement rules off of the text, that's like super hard. But with machine learning and just having it feed through this model, then it's much easier. And the trick is that you have to have a lot of data of previous examples that you've tagged in order to train your model. So as long as you have a lot of previous data where you have the inputs and you specify that this is the output for those inputs, then you can run all that previous data into AutoML and modify the pre-trained models they have to customize it to your environment. Does that make sense?
Yeah. Yeah.
Okay.
Good. Thanks.
Yeah, no problem. The second thing that sort of typifies the state of cloud computing today has to do with these kind of related similar services on both the AWS and GCP side. On the AWS, it's this thing AWS Direct Connect, and on GCP, they have an Interconnect. Very similar sounding names. Actually, a lot of the services, funny enough, the names are somewhat similar. But both of these are aimed at hybrid environments. And more than likely, a lot of you don't necessarily think about this stuff or care about it per se, but it's important for a very specific reason. So a hybrid environment is one in which you don't have everything in either in the cloud or in a particular cloud provider. You basically have some stuff, let's say at GCP, at Google Cloud, and then some stuff what they like to call on-prem or on-premise. So like you still have your server in your basement. So your server in your basement, stuff at Google, and maybe some other stuff at AWS. Like, so you have things at different clouds or locally, right? And when you do that, in the past, there was a huge performance hit and security issues with doing that. That for any bank, like the inability to have things in those different locations was a huge problem for banks, because their thought process is like, okay, if we want to, even if there's like huge value to going to the cloud, we have to spend all this time and effort to like basically move everything at once. And it's this like huge, massive effort. And then like, how do we, just like with application development, like it's the same thing with like, the difference between moving just like a piece of your app, like rewriting a small piece, or like rewriting the entire thing, right? And so because both AWS and Google Cloud have placed such a huge emphasis on enabling hybrid environments with these technologies and other similar ones, now, like literally this year is the first time when larger enterprises on like a whole are like we've crossed over the threshold where everybody is just like, okay, this is a proven model. Now it's just a matter of just doing it. And so you see everybody starting to utilize these hybrid models and not move everything once, but just start moving anything over, anything that they can piecemeal. And that will eventually snowball. And undoubtedly, you know, over the next couple years, 10 years, whatever it'll take, I'm sure a large majority of even the bigger enterprises will have everything in the cloud. So as much as you think that, you know, everybody does everything in the cloud right now, it actually isn't the case. But the pace at which everything is moving there has picked up rapidly over the past, you know, year. All right, and then the third thing, talking about kind of the state of cloud computing today. So these are all AWS services. You know, it's funny. Both AWS and GCP love their icons. I always wonder about the designer who like has to intricately come up with these like 50 million like different icons that are slightly different in whatever ways. But
they all seem to tell a bit of a story, right?
Yeah,
they're able to get these things that actually tie into what they actually are representing.
Yeah, it's definitely a full-time job.
Yeah.
Does anybody? You don't have to tell me, but like I would imagine that nobody could like know every couple of them or whatever. But they each represent different AWS services. On the left side are basically different levels of compute within AWS.
I guess Lambda, correct?
Yes. Oh, actually, you recognize Lambda. That's pretty good. Yeah, the only one that, other than when I did this presentation, the only one I knew was EC2. Okay. So these are all different levels, starting from the bottom where it's like more, you know, less managed. You have more access to like closer to the metal. So Lightsail is just virtual servers. You basically get a whole virtual server, and it's very cheap or whatever. They also at this level, I didn't put it here, but you can also just, excuse me, you can also get just VMware instances as well, like just old school VMware instances in AWS, which is similar to the Lightsail level. But then like a level up is this, the most popular is obviously EC2, you know, Amazon's virtual instances. But you can go like a level above that to get like much smaller in container services, you know, using Docker. Fargate is like a level above that, a little bit more managed with where they basically, you're still doing Docker, but you don't have to like specify the clusters or like any of the details. You just give it some memory requirements and it handles all the deployment. And then a level above that is Lambda, is the serverless environments, which I know that like serverless is something that like you hear all the time. The one definition I read where I think it made the most sense to me is that serverless is where if your application is not actively running and doing something, then the instance gets destroyed, that it's just not there. So like that essentially is serverless, that like if you aren't actually processing something, there's literally nothing there. Whereas if you do want to always keep it active, then that's not technically serverless. And then on the other side, these are different levels of deployments. So I mean, and there's similar stuff to all this on the Google Cloud side, but you know, at the top, Beanstalk is the most managed of the deployment mechanisms, where you can, I mean, in like 5 minutes, you can just specify that you want a node API and it will do everything for you like really quickly. And you don't have to think about servers or instances or scaling or anything like that. It does everything for you behind the scenes. OpsWorks is a little bit more detailed, where you're dealing with chef scripts. you can use some of their defaults, but you're customizing a little bit. And then CloudFormation is where you get into like the nitty gritty and you're writing your own kind of scripts. It's a very powerful platform, but requires a little bit more learning. So the thing with all of this is that I wanted to point out is that, over time, each one of these, like for the most part, you could take on either side of this, you could take one of these levels and just run with it for your entire application for the most part. So like on the right side, I as long as Beanstalk, there's a couple things that don't work in Beanstalk, like for your application. Like if you were trying to deploy a Go application, actually no, you can. In fact, Beanstalk now supports Docker deployments, so I guess you could do that even. But the point is that if you wanted to build your application in Beanstalk, there's no reason why you can't. You could do the same exact thing in CloudFormation. The difference is between how quickly, there's a trade-off of basically how quickly you can do something without any prior knowledge, which the stuff at like the top is sort of at that level, versus as you kind of go down the stacks here, you need more knowledge and requires a little bit more time, but you have a lot more flexibility and more options. And also, generally speaking, there's different. Well, you don't pay for anything on the right side. On the left side, there are some different pricing or whatever, but it gets a little bit. There's at least that's a consideration, but it's not quite straightforward. So the point is, though, that there's different levels of entry depending on your where you're coming from and like what your aptitude is and your appetite for doing some of this. And I think the thing that I'm trying to point out here is that on both the AWS and Google side, they've done a really, really good job of basically identifying all the different potential entry points for basically any developer or product person, and making things easy for them to get started. And you really, really see that now that like you obviously know that once you get on using their service, you're very unlikely to move off it. And so they want to make it as easy as possible and ensure that whatever the needs of your application, they can fit it. And I think at this point, the maturity level has reached something where, I mean, it would be very hard, and it's very hard for me to even think of an example where you would not be able to support whatever crazy application you're thinking about building.
On the idea of getting onto one of these platforms and then being unlikely to move off of it, one of the criticisms or hardships that I've heard about with some of these is like if you come in and you build a lot of lambda functions and you put a lot of infrastructure there for your application, but then you decide, well, Amazon is now becoming too expensive for me, and I want to shop around and find something else. That maybe it's difficult to move from one to the other. Do you find that to be the case, or not so much these days?
So it can be. I think, and this is one thing that I didn't include in this, but I could. I'll try to do some addendum stuff that I'll follow up with you guys on. But there's definitely some best practices for how to essentially abstract out the cloud. And for Lambda is actually a really great example, because there's no reason why you can't structure your code in such a way that Lambda is a very thin veneer on top of your application. At the end of the day, what is Lambda besides like an asynchronous piece of code? And you should, like, let's say you're using Node, for example, if you're thinking in terms of trying to limit the kind of reach and abstraction of these specific platforms, you should be able to create a set of your services, break it up into separate services of whatever your serverless pieces of functionality is, just by itself, that you can run from the command line or whatever without Lambda, and then just have that as kind of like a very thin shell on top of it that calls into your functions. Does that make sense?
Yeah.
That's just with Lambda, but like there's with a lot of the other services, there are other like tricks and that type of thing you use. But the main gist is that it is important, and you bring it up a good point, to be conscious of that and to make sure that you don't let the specific platforms bleed too much like throughout your code base, because that does make it harder to move.
Okay, thanks, Jeff.
No problem. So yeah, I mean, there's a ton of services. I threw up this that has like a bunch of different ones at AWS. I mean, but there's way more even than are listed here. And it's growing. It's growing all the time, every month, every year. And the market is growing, sort of as I allude to. This is from 2007, and AWS, not surprising, is at the top. I was actually surprised at IBM Cloud. I didn't even know that IBM had a cloud, I guess. But yeah, Azure's been doing a good job with the enterprise like they always do. But the interesting thing I found is that for Google Cloud, they're sort of, even though their network, they've been using essentially all of the cloud services internally for a long time. But and so they're sort of latecomers, relatively speaking, but they've just in the past couple of years really matured their offering, where it's feature parity for the most part with AWS, and basically it's been increasing at a faster rate than all of the other ones, and they're pouring more and more money and resources into the platform. Google definitely sees it as a major strategic opportunity for them.
I was a little surprised that Salesforce is as far down that list as it is, but I guess it's a little more of a niche.
I think so. Like, it's not as general purpose as the other ones.
Yeah.
This is just saying about how the market is it keeps on going up and up, and for a lot of the reasons I mentioned, like when I talked about the servers and racks or whatever, this still does exist in a lot of the enterprises, but because of those interconnect and direct connect services, that's where the huge growth is going to be occurring over the next couple of years, where it's a point where, what is it? It's a doubling of the market in the next couple of years. And this is where you just give like a quick little plug. I mean, this is where some of the stuff that we've been doing really comes in. So I mentioned with GetHuman, we're focused on this customer service stuff, but we've been starting to do a couple other things after, getting really into a lot of the AWS and Google Cloud for our own purposes. We started working with some of the other companies to help them optimize their own infrastructures, and we ended up creating a service for it called VendorSmith. And the whole purpose of this service is to both help you kind of strategically come up with a plan for how to best utilize your cloud environments, but then also we leverage the fact that every player in the market right now is hungry to gain market share. It's one of these things where there's so much of the pie still left that they are willing to very often make deals, private deals, with people that are committing to increased usage over time. And so we are kind of leveraging that to, in addition to kind of helping people just know the best way to set up their architectures and manage their services, we actually negotiate a lot of private deals for people, especially people that migrate to, for the first time, or are going to be, using an increased amount. The basic rule is that if you know you're going to start using a new service on AWS or Google Cloud, make sure that you try to negotiate with them to get a deal, some free credits or something like that. Most of the time, they will do it. And if you need any help, let us know.
Hey, Jeff.
Yeah.
Before you move on to the next thing, I just noticed that there was a question about lambda functions.
Sure.
Noticing. So Felix is asking, are you able to debug lambda functions locally?
Well, yeah, because with the way that I described it, so there's a couple things. Like locally, typically, the way I do it is I don't run lambda locally. I'll just run my code from the command line, because that you should abstract it in such a way that you should be able to do that. And then it's just like any other node program, or if you're using some other language, similar type thing. But there are emulators both on the AWS and Google side. To be frank, I don't use those, so I don't know a lot about them. But you should be able to. Yeah, I don't think that there's that much that would be different, unless you were doing something. Trying to think whether there would be any potential issue, or if I don't think I've ever had any issues like where like locally it worked, and then when I deployed it out, it like didn't work. Oh, actually, okay. No, there is one thing to be careful of, is that with Lambda and on the Google side, the Firebase functions or Google Cloud functions, they do have a restricted environment. That for like Node, let's say it is like Node like 8 point something or whatever. So like I have run into issues for that because the Node environments were different. So like obviously like that type of stuff you need workshop, and in which case like it does help to do the emulator, because then it will show you those types of errors. But one thing I haven't done myself, but I'm going to, on my list of to-dos or whatever, is that on the Google side, they have a new thing called Knative that allows you to do serverless containers, which is super awesome, because then it doesn't matter what the basic serverless offering is. Like it's the same thing on the Firebase function side, that they limit it to Node 8, whatever, and I want to use the latest version of Node. So if you can do containers in the same serverless managed service, then you can define whatever environment you want, which is what we are definitely going to do.
Awesome.
Okay. So originally, I wanted to have a deep comparison of what we've learned. So over the past 6 months, I've converted one of our bigger applications from AWS to GCP to Google Cloud, and one of our clients, and a lot of like learnings. It was really interesting. And I started to compile a list of like comparison of the different services and my thoughts. I didn't get that done. I have like a spreadsheet with a whole bunch of data in it. I am definitely going to publish this once I get it done. So that'll be another like follow-up type thing. But maybe at the end, like for sure, any questions you guys have either during this presentation, right after I'm done, or right after or afterwards, if you want to send me a message about comparing and contrasting different services. I can't say that I've experienced with every single one, but I did a pretty good look through a lot of them. So I have thoughts on a lot of these if you had a specific question. But I did want to talk about one specific set of things, which is why before I started migrating stuff to GCP, I knew that it was cheaper. But like and that was one of our impetuses. But like also is I just wanted to learn it. And as I was learning more about it, I came up with kind of 5 things of, not that I think GCP is better, because like a lot of it's like in the eye of the beholder, or like it's arguable or whatever. But I guess reasons why I like GCP, I'll say, and which, in depending on your situation, are maybe considerations of why you might pick it over AWS. With the caveat, I'll say that I like both of them, and AWS is great. It's mature. It has a bunch of offerings, but
Jeff, you still there? We seem to have lost you. Jeff.
Yeah, I know, right? I know, right?
Let's see.
Okay. All right, cool. Yeah. Okay, cool. I know a lot of my all the way to, yeah.
All right. Looks like we lost Jeff there. Going to give him a moment to see if he makes it back in. So bear with us for a moment.
You guys use the cloud in your current places at all? Yeah, we mess with Firebase. So, yeah. Our VP. So you guys were using hypervisor, VMs, or? Okay. Okay. I had VMs. I'm trying to get rid of, we're trying, I really want to move us out of VMs. I mean, we have VMs in the cloud, but kind of like, you're in the cloud, it kind of defeats the purpose of using VMs, because you're not really taking advantage of what the cloud has to offer. So, I would like
last
to.
company.
Oh yeah, you can serve it like it's you can get pretty. I think the networking in the cloud is pretty fast.
Redundancy.
Yeah, if you set it up right, yeah, you don't have to worry about none of this. You set it up right. I think I'm becoming a lot more partial to microservice architecture and service architecture.
We're starting to get into microservices.
Yeah, I think that's.
It's a little bit more. Takes a lot more.
It takes a lot. It takes a lot more knowledge of networking and how everything should work together. But I think that that's kind of the way to go.
But I like this.
Exactly. You have to everything. Absolutely.
So if one thing dead,
They all have like developers.
we all can do it.
Yeah. Nah.
You got to worry about. You can change it.
AWS Services.
Hey guys, we're still trying to get back with Jeff. We're gonna give him just a few more minutes here, and if we don't find him, then we'll reschedule for getting the rest of this. So bear with us for just another couple of minutes. All right, guys, looks like we're not going to get Jeff back here tonight. So we got a lot of good information from him already. So we'll see if for the rest of his presentation, if we can schedule him back sometime soon. All right, thanks everyone for joining. Have a good night.